Hello there, it's Alana, and I'm here to help you with this question, which is 8.2, number 23 from the study plan. It's not actually a particularly hard question, it's just kind of weird. So let me view an example over here. All right, so it says a researcher studying public opinion of proposed Social Security changes obtains a simple random sample of 35 adult Americans and asks them whether or not they support the proposed changes. To say that the distribution of the sample sample proportion of adults who respond yes is approximately normal, how many more adult Americans does the researcher need to sample in the following cases? Okay, so, and they mention it right here, but let me just put it, let me bring up the notes from chapter 8. Here they are. So in chapter 8, we ran into the central limit theorem for, it's not really central limit theorem, but the sampling distribution of p hat. And you'll notice the first bullet hit says the shape of the sampling distribution of p hat is approximately normal provided that n times p times 1 minus p is greater than or equal to 10. Which means for this problem, you're essentially solving sort of an algebra problem rather than a statistics problem. Let me grab a fresh worksheet. Hold on. So file. Let me just create this. Okay, so we need n, you won't be able to see that, hold on, n times p times 1 minus p to be greater than or equal to 10. Okay, so we're looking for n. We don't know what n is, but we do know what p is because they gave it to us. P is 0.12. Okay, so we say, okay, it's times 0.12 times 1 minus 0.12, and that has to be greater than or equal to 10. Oops, 10. There we go. Okay, so I'm going to find what this is. 0.12 times 1 minus 0.12, and you could use a calculator, you could use Excel, whatever. 0.12, 1 minus that, enter. Oh, this will be good if I do it this way. Ha ha ha. Okay, so hold on. Let me move these over. I'm going to be so crafty. Okay, so this is p, right? And this is 1 minus p. Okay, so then p times 1 minus p will be equal to 0.12 times 0.18 or 0.8. This is actually really smart to do this in Excel. You'll see why. Okay, so then to find n must be, oh, let me see. Let me bring back the word thing here. Okay. Oopsie, right here. So we know this is n times 0.1056. I think that was that. Let me bring that video back. Oh, there it is. Okay. So must be greater than, oh, for the love of goodness, greater than or equal to 10. All right. So then to solve for n, we need to divide both sides by that 0.1056. You do it to the left, you got to do it to the right to keep things fair and balanced. Okay, and so then n must be greater than or equal to whatever that is, right? So let me go back to Excel. N must be greater than or equal to, there's no good way to do that symbol there, and then it's equal to 10 divided by that cell. Cool? All right, and then we're going to have to round, right? So n must be greater than or equal to, and we're going to have to round up. So round up is actually a function. Round up. Oh, they probably want digits. Yep, 0. There we go. So we need to have greater than 95. Now remember, they already polled a certain number of people. Let me see here. They've already asked 35 people. We're saying it has to be greater than 95, right? Or no, I think that's what. Let me go back and grab that. Yeah, they polled 35 people. So we actually need n0, let's say like our null 0. I don't know how to do that. N0 would be equal to 35. That's how many people they polled. So the n, the additional sample is equal to 95 take away 35. So we need 60 more people. Now let's see if that matches what they do. If not, then I'll have to go back to the drawing board here. Yep, see 95 and then 60, right? Because they already are going to poll 35 people. Cool. And then, so they've got to ask 6 more people, and then they're just going to have you do it over again, it looks like, but with 17%, right? Okay, so the beautiful thing is if you do it in Excel, you can just kind of drag over and then change this to 0.17, and then everything changes accordingly. And you need 35 additional people. Let's see if that jives with what they say. Oh, they say 36. How did that happen? Maybe I didn't round right. Let me see. 71. Oh, that's why. It changed that from 35 to 36. We don't want that to change. We want that to be 35 still, because that hasn't changed. That's just a factor of here. I'll show you. If I drag a row across, oh, it didn't do it then. Hold on. Come here. Sometimes when you drag across, it'll actually change the numbers on them like that. So just be careful. If that happens, just go in and change it. Make it 35, 35 every time. Cool. So that's the actual answers that they were looking for right there. And then let me, this was just the work I was doing. So this was 94.697, which means n is greater than or equal to 96 or 95. Sorry, that was 94.697. Cool. 95. And then let me paste this in. Hold on one sec. There it is. So that's the work involved. It's actually algebra work involved to figure out how this would work over here for Excel. So that's explaining where this little bit right here comes from. That's all this is explaining that. Cool. All right, I hope that helps with that problem. And boy, was part B easy once you knew part A for sure. All right, talk to you later.